Yes.
So today, you guys are going to be able to identify and use set notation. So all those different number sets that we talked about for a period yesterday. Yes, what we talked about yesterday. We are going to use them within a proper notation of different things. Okay. So 1-1 set builder and interval notation. Okay. Your first page is the one that has the empty curly brackets, like so. Yes. Okay, and so let's talk about this. Sets and their notation. A set is a collection of things. A set is a collection of things. Okay? Those things can be anything from, so this would be really anything, but in math they're generally used for numbers. All right? Curly brackets, which are what you see off to the side, are referred to as set brackets or braces. And are used to contain these sets. Okay? That's what they are. They are called elements. Those things that are within the set, they're called elements, or they are called members of those respective sets. Okay? So here's an example of sets. A-E-I-O-U, symbol, 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 2468, 13579. Okay, these are all examples of how the curly brackets are used with relationship to sets, okay? What would the name be for that first set? Vowels. Yes. Okay, so this would be an example of a vowels set. I said volume. Wow, I can't spell. Forward. Vowels. How do you spell vowels? Thank you. That's why I teach math, not English. Okay? What about that one in the middle? Music signs. What are those signs called? Notes. Yes. Music notes. For those who play an instrument, those are sharp. That is the bass clef. Oh, I'm rusty. That's a quarter note. That's the last one. What's the third one? Music people. Quarter and eighth. A whole note is the open one, right? Ooh, music theory. I ain't taking that since like 7th grade. All right. What about the third one? Even what? Numbers. Even numbers. Okay. You could even say even pictures, even natural numbers. Okay. And the last one? Odd numbers. Okay. Now, we want to be very careful about this here, okay? Even numbers, odd numbers. Is it all the even numbers that are there or all the odd numbers? So you want to be specific. This is the what? The first how many? The first 4 even numbers. And this will be the first 5, okay? Because remember, you want to describe the sets as accurately as possible. By saying even numbers, just they are, but that would mean they would include all of them. If this had a comma with an additional dot, 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 then we could say even numbers because that dot, dot, dot means what? Yeah, it keeps going until infinity. All right? What are the elements of the third set? That's right, the numbers in it. So it'll be 2, 4, 6, and 8. Remember, the things that make up the set are called its elements or its members. Simple enough? Okay. Sometimes you'll see 3 dots. Like I said, sometimes you'll see 3 dots before and after the elements for a set. Before or after. So if you see it before, what does that mean? Huh? There's numbers before it, such as 0, -2, -4, and so on and so forth. These dots are called what? What's the official name for these dots? What is it? They are ellipses. Which mean omission or things left out. Sucks with ellipses. I are called infinite sets because they go on for infinity in one direction or the other. Sets without ellipses are called what types of sets? Finite. Questions? A little bit of vocabulary before we actually get to writing our own sets, defining our own sets. Okay? There are two main ways to write sets to describe the elements of a set. There are two different ways. Okay? They are called set builder notation and interval notation. So two main ways, set builder and interval. Raise your hand if you've heard of either of these two. You? Okay? Which one you use depends on the set you're working with. To be honest, sometimes set builder is easier. Sometimes interval is easier. It just kind of depends on what exactly you're working with. So here's an example of set builder notation, okay? You see it has the curly brackets involved. There's a variable. There's a vertical bar. There's some other things. Oops, and there's even that symbol for what? Integers. There's that symbol for integers. So all of these pieces make up set builder notation. And it is read as, you can kind of piece together based off of what's in the parentheses, the set of all x values such that, which is that vertical bar, then whatever sets of numbers we're talking about. So this part here can change depending on what types of numbers we're dealing with. In this particular case, it's read as such that x is greater than 5, and x is an element. That's what that symbol means, that E, of integers. That is how you would read that entire notation. So the setup indicates the curly brackets, all x, what variable we're dealing with, such that, vertical bar, x is greater than 5, and then x is only the integers that are greater than 5. Okay? Question? You guys do this in algebra 2? No, they
Format, but I don't think
not often.
not
Not in depth. All right. Well, let's give it a try. Let's practice this, okay? I'll do. Let's see. We got 1, 2, 3, 4, 5, 6. Okay. I'll do 2 of them with you, and then I want you guys to try the other 4 on your own. It says the set of all real numbers less than -2. The set of all real numbers less than -2. Well, since we're writing this in set builder notation, we know we need the what? The curly brackets, okay? So we need the curly brackets. Do the best curly brackets that you can, okay? What will come after the first curly bracket? And the x, depending on, sometimes if it gives you like a, say you're solving an equation and you have to write the answer in set builder, whatever the variable is in that problem, you'll use that variable. If we're talking about domain and range, if it's range, we'll use y. So it kind of depends. If it doesn't specify, then we exercise.
But it's always a variable. It's never a number.
Correct. Right? Set of x values. All the real numbers less than -2. So we also need the what in this?
The line.
That line, that vertical bar. How would I represent x is less than -2?
By X, the less than sign.
With your hands, is it the one with my left hand or the one with my right hand? The left hand, okay, so X is less than -2. Now I need that condition. What types of numbers are we talking about? Real numbers. Do you guys remember the symbol for real numbers?
R.
It's the R. So you'll have X is an element of real numbers. And that's how you write in the second builder notation. Questions?
What were all the symbols again?
So you have R for real. We know we have what for integer? Z. So this is integer. What's rational? Q. Remember it's the quotient. Whole. The W. And natural. Yeah. So it's all your symbols. Okay? Now this one is a picture. Okay? It's a picture of a number line. I have an open circle, and I have a closed circle. Okay? Do you guys remember what the open circle and the closed circle meant? When it came to the symbols?
Open circle does not include the number. Closed circle includes the number it's over.
That's right. So not included, included the equal to symbol when it comes to the inequalities. Okay? So I know I'm looking for the set of X such that, that's pretty standard in all of them. It really is the condition that changes. How do I represent this picture? We're gonna write these and basically we're writing this in set builder notation.
Do you have to write two of them? Like one of them? X and then X is less than -2.
Okay, we could write it as two separate ones. X is greater than -1. X is less than or equal to 2, but there is a way to write this as a compound inequality. Mia?
Can you put like the X in the middle between the two?
Yep, you can put the X in the middle between the two. Compound inequality. Okay? On this side, we would have what? -1. Okay? And you still would have the less than symbol, because so it's basically saying -1 is less than X. Okay, X is talking about all these numbers in between. And then on this end, we would put the 2, and we still would need the less than or equal to symbol. Remember, in compound inequalities, back from like Algebra 1 days, they all point in the same direction. So they're either all going to point to the left or all going to point to the right. To be honest, they never all point to the right. You just point to the left. It makes it a lot easier. Okay? X is an element of what types of numbers? What numbers are included in between -1 and 2? Real numbers. Not just 0 and 1. There's infinitely many numbers that lie in between there. Okay? Like square root of 1/3 is here. Kind of getting it? Following along? Want to do one more together? Let's do one more. The set of all integers that are multiples of 7. Ooh. The set of all integers, so we only want integers, that are multiples of 7. What do I need to start with? Curly brackets, X, and then the line. How do I represent multiples of 7? And X near it. So, like this. I can definitely put that. But do I need the parentheses? So I could just put 7X. And think about it. 14. That's a multiple of 7, isn't it? That's 7 times 2. 49. That's 7 times 7. So anytime it talks about multiples, you can just put that number and a variable, because it's really truly the numbers that you're plugging in for X are going to give you a multiple result. X is an element of what types of numbers? Integers. because that's all that we're plugging in. If we try to plug in a rational number, we're not going to get a multiple of 7. Okay? So when you're writing in set builder notation, you want to have pretty much the basics, which is the curly bracket, the X, and the bar. Whatever we're talking about, whether it's the picture, whether it's the less than -2, whether it's the multiple of 7, how do we represent what types of numbers we're dealing with, and then what kind of numbers are they? Classify them. Okay? Try the next 3 on your own. You guys can work together. All right, so let's take a look at these. You know, it's short period, so I want to make sure we can get through all 12 of these slides, and we still got to, go over interval notation as well. All right, so for these, we're looking for the set of x values such that x starts at 2/3 and is added to positive multiples of 4. This one's pretty loaded, okay? So we have the set of all x such that, like this is literally the same notation, the same wording as before, okay? So anytime you see that, just like before, you know that we need that basic setup. X starts at 2/3. If it starts there, that means you probably should have it written down somewhere, right? Kind of like what the y-intercept would be in slope-intercept form, that starting point, okay? 2/3. And is added to, added means plus positive multiples of 4. Now this you have to be careful about. You have multiples of 4 just like before, just like the previous one where you have multiples of 7, okay? But it's only positive multiples of 4. Interesting.
Would it just be that the letter at the end would be like whole numbers?
Okay, so a couple of things. Interesting enough, you say, can we put the absolute value bars in there? We could put the absolute value bars in there, but, and then we could also say that, at the end that it's, only your whole numbers. But the issue is the variable. That's really the true issue. Because one, we only want the positive multiples of 4. And if we're talking about the set of all x values that this could work for, we're technically talking about all the real numbers that this could work for x. Okay? So whatever number we plug in that's a multiple of 4, we're adding 2/3 to it. So when we add 2/3 to any multiple number, which is an integer, we're going to end up with something that is not an integer anymore. Okay, it's a rational number. So we're looking at different number sets here. So we do need a 4, but we're not going to use the same variable as x. Because x can be any number that's a multiple of 4 plus 2/3, like 12 and 2/3, or 16 and 2/3. Are you following me? Maybe a little bit? So we need another variable here to represent those multiples of 4. Somebody give me a variable. Y. Okay? So in a case like this, we need to make sure that we identify what numbers x could be and then what numbers y could be. Y specifically needs to be what types of numbers? Positive numbers. Okay, in order for it to be a multiple, they have to be positive what numbers? Positive whole numbers. Okay, so we need positive whole numbers. What are whole numbers? 0, 1, 2, 3. If I were to plug in 0 here, is 0 a multiple of 4? So we can't use actually whole numbers. We actually need what types of numbers? Natural. Okay, so we got to be careful there. And then we also need to describe the types of numbers that x is going to be. What is x going to be?
All real numbers.
All real numbers. This one was a tricky one. So to recap, the y takes care of the multiples of 4 part, the different types of numbers that we can have that are multiples of 4. The x takes care of the actual full expression, those numbers plus 2/3. Okay? That was tricky. Did we get the next one? Maybe? Sure are. The set of x values such that, how do I represent this first part?
Negative 2 less than or equal to x less than negative 1.
How do I represent this part?
X greater than or equal to 1.
How do I connect them together?
Comma.
A comma. If you have multiple pieces on a number line, you just connect them with a comma.
Teachers, excuse the interruption now.
What type of numbers is X?
All real numbers.
All real numbers. Good. That's always encouraging. What about the last one?
Wouldn't the variable change to g?
The variable would change to g because it's set up g instead of all g. So our variable is g with the line such that g is a natural number. The element sign and then n. We don't have any type of restriction. We're not saying just the g values that are between 1 and 2. We're talking about all the natural numbers that there are. So we won't even have this middle part. We'll just have the classification of the number. Yes? Technically, yes. That would be fine. That would be fine. Because natural numbers are numbers that are 1, 2, 3, all your counting numbers, and then you have comma g as an element of n. So you would need to have that. Because with just that inequality, you're saying every possible number that's greater than 1. But you want to be specific that it's only your natural numbers. Question? Let's look at interval notation. Interval notation is the other way to represent or describe different types of numbers. These are numbers that have endpoints on a particular interval. There's a difference between using brackets and parentheses. There's a union involved. Has anybody ever seen this notation before? I think this might be what you potentially are more familiar with. Remember, these square brackets means that the number is included. The parenthesis means that it's not included. Okay? What this looks like on a number line is what you see below. 2 is included all the way up to 5 not included, and everything greater than 2. Anytime you have multiple pieces, you connect them with the union. So unions are used with interval notation. Commas are used with curly brackets with set builder notation.
How do you know like which ones to use?
What do you, oh, it's depending on the type of problem that you have. Okay. So for example, that last one that we did on the other page. So this one right here, you would only be able to use set builder notation because we're talking about specific numbers. We're talking about 1, 2, 3, 4, 5, 6, 7. There's no way to write this last one in the interval notation because we're talking about certain numbers, specific numbers. Even though it's infinitely many numbers, it is specific set numbers. If we're talking about a range, like this one here, we could definitely use interval notation for this one. But anytime that we're able to like list the numbers out, set notation is going to be the only way that you can do it.
So this one's for like specifying all real numbers or integer.
Mm-hmm. And I mean, you can even use, for this, like you can use interval for the first one, you can use interval notation for as well.
Just for whatever you use all real numbers.
Mm-hmm. But this one is specifically for ranges, okay, not listing out numbers. Negative and positive infinity always have parentheses because you can't include a number that you don't know. We don't know what infinity is. It means forever. Okay? So you always put a parenthesis around infinity. And like I said before, anytime you're talking about multiple sets, you would use the union. That's what the use stands for. Okay? It connects them together. Question? All right. So, if you notice, it's kind of a similar setup from the other one. But look at this here. It doesn't say anything about any multiples of 4 or a specific number set, okay? That's only for set builder notation. They'll give you things like equal to or less than, in between these two numbers, less than or equal to. You see what I'm saying? Like that would, you can use interval notation for those. But anytime we're talking about multiples of a certain number or a particular set of numbers, set builder, okay? The set of all real numbers equal to or less than -2. We know how to write that in set builder notation. That was the very first one from before. How would I write it as interval notation? Nope, not for interval. It's either going to be parentheses, square brackets, and unions if we have multiple pieces. Parentheses.
Negative, the infinity.
It'll be negative infinity, comma. All right. On a number line, what would this look like? The set of real numbers equal to or less than -2. I'm going to use this number line down here.
Should be -2.
-2.
Dot on top, and a line pointing back.
Line pointing back. Okay, this is what this would look like. This is what number 1 would look like. Think of this. What number is this way? -3, -4, -5, like all the way over there. Negative infinity. So I'm basically starting from negative infinity and I'm going all the way to what number? -2. Okay? Then I have a stopping point. And I'm going to put a parenthesis here, and I'm going to put a bracket here.
A bracket.
A square bracket. Because remember, the square bracket means that it's included. The open circle is the parenthesis, means that it's not included. Okay? So for these, try to get a visual of what this could potentially look like. So this one was for that one right there. Let's look at number 2. What's the furthest left that we go?
The -1.
The -1. What's going to go around the -1?
A parenthesis.
Parentheses. Going to the right, comma 2 with a bracket. Okay? If we had multiple of these, you would put the union and then you would keep going from there. But we'll always go from left to right. How far left are the numbers that we're talking about to how far right are the numbers that we're talking about? Okay? This one, it says all the numbers between -2 and 6, including or between 7 and 32, including. Okay? What does including mean? Square brackets around these two. Union. Square brackets around 7 and 32. So we have from -2 to 6, all the numbers in between, square bracket, or, which is the union, square bracket 7 to 32, including. Did we get that?
Mm-hmm.
We'll keep going with the rest of them, but you guys make sure we get through these. A number between -4 to 8, not including 8. Well, if it's not including 8, what does that mean? Parentheses around the 8. But a bracket around the -4. For the next one, I have 2 pieces, which means I need a what in between them? A union. Let's look at the one on the left. -2. With the parentheses around -1.
And bracket 1.
With a parentheses. And interval can be simple. The one downside I would say to interval is like if you have multiple of these, then it gets pretty tedious. Okay, it can get pretty tedious. I like set because a lot of times I can represent some of these just with a greater than symbol or less than symbol. That's why it's like certain ones you can do either or really and truly, but certain ones are only for set. Sometimes it's easier. What about a number less than or equal to 156?
The parentheses, negative, infinity, comma, 156, and then the bracket.
So on a number line that would look like this, you have 156, close bracket, going this way. And that is interval and set notation. Are there any questions?